Next, I want to invite Lior Bar Shalom from Arbell Energy. You have 5 minutes. Okay. Just a reminder, the QR code is now available to evaluate Adionics, not Arbell Energy.
Hi everyone, can you hear me? Yes. My name is Lior, I'm co-founder and CEO of Arbell Energy. Every hour, the sun provides hundreds of thousands of terawatt to the earth. This is a lot of energy, but we are struggling to convert it in an effectively way. One of the reasons for that is traditional solar cell can convert only 20% from the sun to energy, almost 80% wasted. At the same time, the demand for energy is growing. AI revolution, we need more data centers. And one of the biggest challenges that everyone talk about is the terawatt challenge. As my friend Ilan said, there's just no way to do a terawatt per year on Earth. We have to do it in space. And space is the ideal place for solar cell. In space, you have sun most of the time. In space, you almost don't have night. You'll need less batteries. And when you have more power, you can actually do more mission. But first, let's talk about solar solution. Traditional solar cell is a single junction. Usually it's made from silicon, this one. You have portion of sunlight that it can convert. Usually 1 photon, which means sunlight, can convert 1 electron. The rest of the energy convert mostly to heat, wasted. That's one of the reasons why the theoretical efficiency is 30, but actually is about 20, 21. So scientists come with a very good idea, and they create the multi-junction solution. Actually, what they did, they add more material, one on each other, like a sandwich, in order to get more spectrum of the sunlight. Still, 1 photon can create 1 electron, and they reach to 45, 50. And it's good numbers, but it's a very complex to production, low yield. That's one of the reasons why we can find this solution mostly in space application. But even there, it's a really bottleneck. So we do something else. We use quantum dot. First of all, what is quantum dot? Think about very tiny particle that we can actually control the wavelength by the size of them. So each size absorbs a specific part of the sun spectrum. So actually what we did, we built a structure that allows us to do very wide spectrum of the sunlight, including the infrared, for example. The second thing that we did, called a quantum effect. In our case, 1 photon can create multi-electrons. And when you have more electrons, it's more efficient. And also quantum dot is like ink, so we can actually print it in a cost way of production, room temperature. We can print it on almost any surface that we want. But the breakthrough that we're bringing to the table, our architecture make the most efficient solar cell. With this one, we can do 3x more efficient compared to traditional solar cell. So think about film, wallpaper, sticker that can be extremely lightweight, flexible, and extremely efficient. This is the solar solution that space has been waiting for. In the last 3.5 years, we are doing a development process together with TNO, one of the famous research institutes in the Netherlands. With them, we already made a prototype that proved this technology is actually working. We made very important milestone when we shift to a large scale by 10 by 10 module, and we did it by a slot coding machine, and also the laser scribe to show you that we can do all the package at once. And why it matter? Because traditional solar cell, the one that we spoke about it, the silicon, is usually metrics of 10 by 10 modules. So when you do 10 by 10, it means that you're ready for mass production. So our vision is simple. We want to generate energy from any surface. We will start on Earth, and we will go to the space. Thank you very much.
Thank you, thank you. I just remind the audience that we have a QR code here on the right side of the screen. Judges, Pete, go ahead.
You didn't answer the key question. How expensive is this? compared to a conventional solar cell?
It's a very good question. I try to say when you can print it in a cost production, it means that you can do it in room temperature. It's even cheaper than the silicon. Okay, the silicon today, it's very, very cheap. Think about it. In the silicon, you need to do high temperature. It's no roll to roll. In our case, it's even cheaper than that. So it's another thing that is adventure that we have.
Thank you. What is your next coming milestone and the maturity level of your device?
Right now, we're in TRL 5. The idea is to start to do pilots. Right now, we have a transparent solution, so we start with a retrofit solution. We found that traditional solar cell, the silicon, have degradation of the efficiency, so we can put our solution on top of them and bring back the efficiency. We also can be transparent for all kind of transparent solutions that they already need. The idea that we want to touch the market, to start to collaborate, to start the regulation, to start to do all the testing that we want to do, and this is so it's the next coming weeks we'll do pilots.
Thank you.
Yeah.
Hi, thank you. Oh, thank you. Curious about your business model and scalability with customer integration. It seems that now your solution can be put on existing solutions. In the future, are you planning on being more vertically integrated into their manufacturing supply chain, or can you walk me through that growth?
It's a good one. Actually, right now we focus to develop the technology. It means that we need to do, we have like a roadmap how to create the most efficient solar cell. Right now it's transparent because we need to make it more thicker. The idea that we want to continue the development and focus on that, that's why we want to do collaboration with a design partner in order to bring it faster. The idea is also to do faster. That's part of our journey right now, that we want to collaborate with more places in order to make it faster. We have a roadmap that actually work on that. We have two things to do. First of all, to do the pilot. Secondly, to do more efficient, to make it more thicker. For your question, we need to do some collaboration that we start talk with, and this is part of our journey. We want to do design partner, third-party manufacturer, and after that, to do our own facility for that.